Every spring, you buy fertilizer. Every spring, the company that sold it to you is already counting on next spring's order. How about a method that costs merely a few dollars, lasts 20 years, and needs nothing from anyone? A copper wire. Buried next to your plants. The science behind it is real. The history behind why you never heard of it is even more interesting. So let's find out where this knowledge actually started. The trail does not start in a laboratory. It does not start with a patent or a published paper. It starts in the forests of Bavaria in the 1400s. While keeping meticulous records of soil behavior, German foresters documented what happened when wood was buried in garden plots. They observed a kind of underground transformation that took years to unfold, but once established, it maintained itself without any outside help for 15 to 20 years at a stretch. In areas near copper mines, near streams running over copper-bearing rock, in fields where copper tools had been left and forgotten in the soil, the plants were different. Bigger, more resistant to disease, more productive across consecutive seasons without any additional inputs. Monastery records from the same period describe soil that stayed fertile without external amendment for nearly 2 full decades. This knowledge did not travel through scientific journals. It spread through families, through farming communities, through the careful observations of people who had no incentive to publish, but every reason to pay close attention. However, with the arrival of the 20th century, this knowledge began to be forgotten. But then Justin Christofle came, the man who tried to revive it. Justin Christofle was born in France in 1865. By the early 1900s, he had spent decades farming and chasing a single idea that the scientific community of his time did not have much patience for. He believed that plants were not just fed by the soil beneath them. He believed they were being powered by something above them as well. The atmospheric potential gradient is real and measurable, though most people outside of physics have never heard of the term. On any clear day, the difference in electrical charge between the Earth's surface and the air roughly 30 meters above it is around 300 volts. The Earth carries a negative charge. The atmosphere carries a positive one. Between them runs a slow, continuous, silent flow of electrical energy. Not lightning, not static you can feel. A gentle permanent current that has been flowing since before the first plant took root in any soil anywhere on this planet. Plants already sit inside this natural electric field. Their stems and leaves can carry tiny electrical signals. Their roots are buried in the ground, which has a negative charge. So the plant connects the ground to the air. It acts like a small, natural bridge. In simple terms, a plant is like a living antenna, standing in a weak but constant electric field. Christofle's question was the same one those Bavarian foresters had been circling for 4 centuries without the vocabulary to ask it directly. What happens when you improve what the plant is already doing? Copper conducts electricity roughly 60 times more efficiently than the cells of a plant stem. Shape a length of bare copper wire into a spiral and drive it into the soil near a plant's roots, and you are placing a far more efficient conductor inside the same electrical field the plant is already working with. The spiral concentrates the energy it collects and focuses it toward a single point at root depth, right where it can do the most work. He documented oats growing 5 feet tall. Old trees are returning to full production. He published his findings openly, invited observers to his gardens, and on October 26, 1925, Christofle filed his patent in Switzerland, where the record would be permanent and public. The British government was paying attention. The Electroculture Committee, formed in 1918 under the Ministry of Agriculture, spent nearly 2 decades collecting field reports, yield data, and direct testimonials from experimenters across Europe. They tracked it carefully for 18 years, and then they chose not to share what they found. So, why it disappear? Let's reveal the money behind the silence. The Haber-Bosch process turned nitrogen fertilizer production from a modest operation into an industrial machine. Factories that had made explosives during World War I were retooled to make ammonia. By 1960, global synthetic fertilizer production was approaching 20 million tons per year. The business model was elegant and ruthless. A farmer who buried wood and copper bought materials once and watched the soil improve for 15 to 20 years without further input. 0 external amendments after year 2. A farmer who adopted synthetic fertilizer signed up for a purchase every single spring for the rest of their farming life. One model generated a sale once. The other generated a sale every year forever. Agricultural journals quietly stopped accepting submissions on electroculture. University researchers who needed industry grants learned not to spend their careers on questions the industry found inconvenient. Newspaper editors began filing Christoflow's work alongside perpetual motion machines. The institutional barriers were not dramatic. They just needed to accumulate quietly, and they did. By the late 1930s, electroculture had effectively vanished from serious scientific discourse. The method was not debunked. It was not proven wrong. It was covered over the way you cover anything you do not want people to find, not with argument. With distance, time, and silence. Now think about what those Bavarian foresters were watching in the 1400s, what the monks were recording in their garden journals, what Christoflow spent 30 years trying to explain to people who were not ready to listen. They did not have the vocabulary for action potentials or mycorrhizal networks, but they were watching the same system at work. Here is how it all connects. As buried wood decomposes, the breakdown of linen inside it creates vast fungal networks through the surrounding soil. These mycorrhizal networks are themselves electrically active. They carry signals between connected plants. A plant under pest attack can warn its neighbors through these networks before the insects ever arrive. These fungal threads also increase moisture retention in the surrounding soil by amounts researchers have measured at up to 400% over 5 to 10-year cycles. Copper at low concentrations is a cofactor for several of the enzymes these fungi use in their own metabolism. A slowly oxidizing copper wire releases trace copper ions into the surrounding soil over an entire growing season. Copper is also a genuine plant micronutrient involved directly in the electron transport chain inside chloroplasts, where light is converted to chemical energy. It activates enzymes that build strong cell walls. It supports the plant's immune response. It plays a direct role in fruit set and seed development. Biology, running on electricity, built on wood, and sustained by a sky that never stops sending energy downward. And the remarkable thing is not how complicated it is, but how simple it is to start. Moving ahead, let's explore the proof that came a century late. The modern confirmation came from the Chinese Academy of Agricultural Sciences. 3,600 hectares of open farmland. An area larger than 6,000 football fields. High-voltage lines suspended above the crops amplified the same atmospheric gradient that Christoflow's copper spirals had been reaching toward from the soil side. No synthetic fertilizer added. No pesticides applied. Yields climbed 30%. Pest pressure dropped by 70% in some zones. In certain areas, the reduction reached 100%. Now, if you want to do it yourself, here's how you can proceed. Start with 14-gauge bare copper wire. Not coated. Not insulated. The oxidation process that releases trace copper ions into the soil only works on bare wire. Wrap it into a loose spiral around a wooden dowel 12 to 16 millimeters wide. 3 to 5 turns with enough space between them for air and light to pass through. The finished coil should be between 5 and 20 centimeters in diameter. Drive the dowel into the soil so the coil base sits roughly 10 to 15 centimeters underground with the top of the spiral just above the surface. Position it 10 to 20 centimeters from the base of your plant, adjacent to the root zone, not pressed against it. Point the tip of the spiral toward magnetic north. The Earth's geomagnetic field runs roughly north to south, and the spiral collects more efficiently when oriented along that axis. A compass costs almost nothing. Do not skip this step. If you want to go further, bury wood beneath the bed before you plant. Logs, branches, wood chips from a municipal tree trimming service. Almost any untreated wood works. Bury it at least 30 centimeters down and let the copper spiral sit in the soil above it. The decomposing wood builds the fungal network over years. The copper feeds and conducts through that network from the moment it goes into the ground. You are not just planting a garden at that point. You are building an ecosystem. Set up a control row alongside the experimental one. Same seeds, same water, same soil, everything identical except the buried materials. Measure plant height every 2 weeks. Count flowers. Weigh your harvest at the end of the season. Take notes specific enough to mean something when you come back to them next year. Tomatoes, beans, squash, and cucumbers all respond well. Many growers report the most visible early results with leafy greens. One market gardener tracked his lettuce rows across 2 full seasons. Same soil, same water, same seeds. The only difference was a copper spiral buried in one row and nothing in the other. 40% more lettuce from the copper row. Fewer aphids throughout the season. No powdery mildew at all across either year. And that is actually the oldest form of agricultural science there is. The people doing this today have no particular reason to invent numbers. They are not selling anything. They are just growing food, paying attention, and writing down what they find. The investment is under $5 for the wire. The wood is free from any tree service that would otherwise pay to dispose of it. Once established, the productive cycle runs 15 to 20 years before the timber fully decomposes and needs replacing. Nothing to buy each spring. No subscription. No annual invoice. One copper spiral. Some buried wood underneath it. A compass to find north. That is the entire cost to begin testing something that farmers figured out before modern agriculture existed, that a French inventor documented carefully enough to patent, and that a Chinese research team confirmed at a scale large enough that the numbers stopped being ignorable. The knowledge was never lost. It was made inconvenient. There is a difference, and now you know it.